Hi, I'm Esther.
And I'm Sean.
I write about AI news here at Tech Target.
And I edit Esther's stories.
We're here to talk to tech experts about everything AI, from open and closed models to AI agents and who's ahead in the generative AI race.
And even the elusive AGI.
We've got it covered, right, Sean?
Yep, we've got it covered.
Hello, welcome to another Targeting AI podcast. Today we are talking to James Wang, Director of Product Marketing at Cerebras. Before Cerebras, James was the head of tokens at Ammon, its cryptocurrency financial services firm. Before that, he was an analyst at ARK Investment Management. And before then, he worked at Nvidia. Thank you so much for joining us on the podcast today.
Hey, thank you, Esther.
Okay, so James, before we get into questions about Cerebras, we want to learn a little bit more about you and how you got into technology and what it was like working at Nvidia, let's say, and stuff like that.
Yeah, sure. I got into technology because I was a computer PC gaming nerd when I was a kid, right? I loved computer games. PC games were having their heyday, and I enjoyed them so much that I spent all my time building PC hardware and learning as much about graphics cards as possible, because that was the piece of hardware you needed to make games look and run really well. So from there, basically, I just developed a very deep fascination with computer hardware, CPUs, GPUs. I wrote for a computer magazine in Australia that was like the hardcore PC gaming magazine of its time. And that led me to Nvidia. Essentially, after school, I studied computer engineering, and I figured, hey, I like this hardware so much, I should probably work for one of these companies. And I had a good relationship with the guys at Nvidia, and kind of pretty much came to the US to work for Nvidia after that.
That's a great background. And so you started at Cerebras like a little bit after that. And Cerebras started up in 2015 and competes with Nvidia. How has Cerebras AI strategy changed, would you say, in the last few years since its founding? And in what ways did Gen AI force a change in strategy?
Yeah. So when Cerebras started, they had a very bold idea, which is to build the world's largest computer chip, not by a little bit, by a lot. The standard computer chip at the time was about 600 maybe square millimeters, about the size of a stamp. Cerebras came out, I think 2019 thereabouts, with a chip that is dramatically larger. It's the size of a dinner plate, and nothing like that had ever been done before. So that was a huge revolution. I followed it as an analyst at the time, and it really put it on the map. At the time, there were maybe half a dozen companies trying to compete against Nvidia, companies like Graphcore, Sambanova. They all had slightly different variations on how to beat the GPU, but basically by making a different kind of a existing chip, a smaller chip. Only Cerebras went way, way, way large on a complete different trajectory. And I thought that was probably the only chance anyone had of taking on Nvidia, because if you're just gonna make small changes, Nvidia will catch up and beat you. But Cerebras had a radically different approach, and I figured it would be interesting to join them and try to take that technology further. So when I joined, our main product was around AI training. So building the models such as ChatGPT that can answer questions for you. That's a very technically demanding, very MLs, requires a lot of deep ML expertise. And Cerebras has a lot of great ML researchers. We had some great results from that. But I would say the big change since joining has been our Inference launch. Training the models is great, but every time you send a question to ChatGPT, you want an answer back. And the way it does that is through a process called Inference, which is it takes your string, your question, run it through their model that has been trained, and then it outputs a series of tokens. That's the answer you get back. That's what billion people worldwide are just addicted to now daily, myself included. So we didn't used to do that. We used to only train the models, and then that was it. And then you can use something else to get the answers back. But last August we launched Inference, which is basically our way of serving this kind of request. Running a model to get an answer, and our business has just gone vertical since then. Like the amount of inbound interest, the amount of companies that can use our products, the amount of startups building on Cerebras has just exploded. So it's been very exciting.
Quick follow-up. You mentioned Samanova and GraphCore. Like, do you three have your own kind of niches parallel to Nvidia, or would you say those are direct competitors, or more like just you have your lane, they have their lane?
I would say at this point, we are all essentially going after the same market, right? Which is the LLM market, whether it's training or inference. Some of the competitors only do inference. We started off only doing training. So there was maybe some specialization up front. But today, I would say the bulk of the effort for everyone is going after this inference market, because the inference market is the one that has the least friction for us to enter, right? If you think about trying to compete against NVIDIA for training, you have to convince someone to buy your hardware or rent it in the cloud and then do a bunch of software optimizations for your hardware before you can get any results. For inference, you can abstract away all the underlying hardware on your own and to just offer an API endpoint. An API endpoint is a web programming construct. So the reason why AI has been so successful in the last 2 years is because all the complexity of AI has been abstracted from like deep artificial intelligence research into a web programming construct, so that you no longer have to be a PhD that can do calculus, backpropagation, and clean data sets. That used to be the skill set needed to do AI. Today, the skill set needed to do AI is if you can write a React app, a very thin one, right? Or if you can implement Twilio, you can basically implement world-class AI. That is a very underappreciated and fundamental aspect of what has changed. And that's why we can literally compete for the same market and for the same customers as OpenAI, right? Because if you're using OpenAI to do whatever task you're doing, something very, very elaborate, all you're doing at the end of the day is passing a string of text over to an API and sending it their way. And our product is fundamentally saying, hey, you can send the string our way. We'll give you an answer that's just as good, but twice as fast, 20 times as fast, right? So the level of work needed to use our product is now not even 1% than what it used to be. It's basically completely transparent. You don't even need to know that we have secret hardware.
Okay, so one other thing I want to ask about Nvidia. It always impressed me that you were Cerebras is going up against Nvidia, which is a huge juggernaut. Like, is that intimidating, or did you find your footing because you're still alive and still growing? And so it must be going pretty well. I mean, how do you do that? How do you compete with something like Nvidia?
NVIDIA is just a company like every other company, right? It is mythologized today because they're a $3 trillion company and they've done many things very well to deserve that status. But when I was at NVIDIA, it was like a $10 billion company, and it was a $10 billion company for 10 years. It's the same people. Like nothing to me, that the mythology is easy to break because I was there. I saw what the insides were. Like there's nothing special. Like this is a bunch of guys. We meet in a room. We make some decisions, and but ultimately they executed very well on a very large growing market, right? But it's I know all the people who are building this stuff. They're not like they don't come from Asgard. They're in Santa Clara, right? It's nothing special. We have smart engineers too. So it's only scary to compete against NVIDIA if you're not any better, right? Because they ship relentlessly. And if you're only a little bit better than them, you could be good for 6 months and then you'll be not good in the next 6 months. So the key to competing against them is A, to execute consistently, and B, to have a very large and enduring lead so that you're not just a flash in the pan. And that's why I think Cerebras is unique in that it has a dramatically different approach by an order of magnitude, and that's why it's had an enduring advantage. The most telling story on this front is, so as you know, NVIDIA's next generation hardware is called Blackwell. It is the first time they're using two GPUs together, glued together on a substrate. AI. It is also the first GPU I'd say that like truly blew up. That's built for the modern LLM era of like 1 billion people using ChatGPT. So highly anticipated. It is the benchmark to beat. Now, before this release, some of our competitors like Grok and whatnot have got some nice attention by beating Nvidia's prior generation called Hopper. In these chat applications, whether it's ChatGPT or Llama or whatnot, generally the GPUs can give back answers to a user about 100 tokens per second. So the words you've seen, it just comes back like line by line by line. The AI accelerator companies like us and our competitors can do it at a few hundred in the case of Grok and a few thousand in the case of Cerebras tokens per second. We got some notoriety for beating the GPUs for once, right? These companies that raised money in 2016 to 2017 all claimed to be 10 times better. And until chat LLMs came along, there was no definitive evidence and no way to experience the speed. So we finally got there. But NVIDIA came out with its first Blackwell numbers and was very proud. It was 1,000 tokens per second. So for the first time, GPUs can now also come out with like a whole page of text in one go. And in this single release, NVIDIA has basically obviated the entire lead by the small chip AI competitors, right? Everyone else is essentially, their past generation, Samba Nova, Grok, TPUs, every competitor got smoked by Blackwell last week, right? And oddly enough, we were not in that chart because we hadn't actually submitted that benchmark yet. We were in the process of submitting that benchmark. So we looked at the results with curiosity, and it was like, that's interesting. You have 1,000 tokens per second. It's your first 4-figure result. Congratulations. And this podcast is very timely because as of this morning, we released our performance result for the exact same benchmark, done by exactly the same team that measured their performance, a great team called Artificial Analysis. And our Cerebras Wafer Scale Engine for Inference scored 2,500 tokens per second. So 2.5 times faster than a 8 GPU Blackwell flagship system that is not even generally available yet. So I think this really speaks to the kind of point that to compete against them, you need a large lead. Otherwise, they will erode your lead in one generation and you will not be able to keep up. So after today's release, essentially, Cerebras is the only company in the world that has demonstrated it can beat Blackwell, right? Which is NVIDIA's next generation. I think that's a very unique and distinctive position to be in this market.
Wow, I didn't expect us to come in so hot so soon, but I want to dial it back just a little bit and speak about the Wafer Scale Engine, right? What is Cerebras Wafer Scale Engine? How has it grown and evolved, and what specific AI workload benefits from WSA?
The Cerebras Wafer Scale Engine is the computer chip that the company built. It is the largest chip ever built by anyone. It is about this big, I would say, about the size of a face. It is built in partnership with TSMC, where we developed a process to essentially connect multiple dies together on the wafer. It is, when it first came out, it was one of a kind. And what's interesting is it's many years have passed now, right? This technology is now much better understood. And to this day, we're the only company in the world that has shipped this commercially, that can build this commercially, and that is selling this commercially. No one else has anything similar. NVIDIA's Blackwell GB200 increased the maximum die size or the chip size by around a factor of 2. So NVIDIA can increase its area by a factor of 2 over one generation. The Wafer Scale Engine increased the area by a factor of 50 in a single step, and it has not been repeated. So this is why it's a durable advantage, because it is not a little bit different. It is dramatically different, right? And it is dramatically larger. For example, if you say NVIDIA's next generation will double again, get to 4 on a single interposer, we are still dramatically larger than that. And of course, we are involving our product as well. So it is essentially, but to answer your question, circle back, it's the largest chip ever built and the highest performance AI chip ever built.
Okay, so following that up, this is maybe a silly question, but you don't think of something this big really as a chip. You think of a chip as something like this. Have you guys ever thought of renaming it as something other than a chip?
We call it a wafer scale engine. That's our closest take to naming it that. It is, it does make the word seem a little comical. But I think those who've seen it from us. Kind of once you see it, you understand.
Wafer scale engine. Yeah, that's certainly differentiated. Yeah.
Moving on to like your partnerships, Cerebras recently partnered with Aramco, Saudi Arabia's oil company. What can you say about the partnership? How will the oil company use Cerebras CS3 AI supercomputers to develop LLMs?
Yeah, we have a lot of partnerships, including with them and with our good friends G42 in UAE. Essentially, those customers are very motivated to build an AI centric economy in their region of the world. They partner with a lot of companies, right? They partner with Nvidia, they partner with us, and I think for them it's important to, since it is a new industry for them, they want to be leaders in that industry. Buying Nvidia obviously makes a lot of sense, but it also makes sense to like have options that exceed what can be done on GPUs, because everyone has GPUs. You cannot be better than everyone else if you just merely have the same thing, right? So we are the way to think about it, I think, is Cerebras gives you differentiation, right? It gives you something you cannot do on the commodity hardware, and that is true, right? There's no amount of Blackwell that can give our performance. So they're very motivated to push the bleeding edge, and that's why we have this fruitful relationship with them. And it's our goal to provide our customers with something that they cannot get on GPUs today, that lets them do something meaningfully different and value add today. The way I like to talk about it is almost like bringing a GPU from the future back to the present, right? Everyone's waiting for the next GPU. Our response to them fundamentally is you don't have to wait. We literally ship you a GPU from 2030 today. You can get it right now, right? That's a very, very compelling proposition.
I have a quick follow up because you're talking about, I love how you're kind of describing yourselves as like, an alternative in terms of where everybody's going small, you guys are going big. Do you think that might turn other like enterprises off? Like think, well, why do I need this like big thing when I can just go small? And also like in terms of resources, right? Because not a lot of enterprises have the ability to, differentiate like you mentioned.
Mm-hmm. That used to be a problem for sure. But in the inference market, this is not a problem at all, because the unit of purchase for them is not something big, right? It used to be that we would be like, hey, we have the most badass thing on the planet, but it's a couple of $1 million. Would you like to buy one, put in your basement? And the CIO tends to drag their feet, right? You can imagine that process doesn't go down well. The new product we sell is a token via an API. You can get one, you can get 1 million, in fact, for free. Any developer just log in and you can get 1 million tokens for free. You can build a nice app with that. If you got good traffic and you want to buy it on a continuous basis, it's 80 cents per million tokens, right? Pay as much as you want or as little as you want. So the unit of purchase is now tiny, and that's wonderful. It means you can reach more people. It means it's a fundamentally disruptive product, because disruptive products are priced at the low end and then they grow over time. Since we launched Inference, this has not become a problem. Basically, it's like they don't. The wonderful thing is they don't even need to know or even care what is creating the tokens. They just care that the tokens can be bought and that they're fast and that they're good. And that's what we sell these days.
Just a quick one as well. You're talking about inferencing. What is the difference between the inferencing? Like what makes something like inferencing market? If you can just expand on that a little bit.
Yes, the inference market is simply when you send a question to a chatbot, right? Like plan me a trip to Tokyo, and then it has to calculate the answers and send it back to you. The answers can only be derived on a high performance AI chip, like a Cerebras Wafer scale engine, like a GPU. You can't do it on kind of like regular old CPU hardware. That's why this market got created. And you can buy the hardware and install it yourself to do this, but most companies, in the cloud era, prefer not to handle hardware. They prefer to just send you continuous requests from millions of users. How do I do this? How do I do that? Chat to me, and then get, millions and millions of answers back. That's the inference market. It is billed by per token, which is roughly saying per word. So the more traffic you return, the more traffic you serve in terms of this exchange of messages, the higher your revenue. So that's the whole market.
Okay, so you've got a bunch of partnerships, and included one with a pretty hot AI search vendor, Perplexity, which actually is putting up some pretty good numbers and slightly eroding Google's dominance in search. I mean, it's significant. Any amount of taking away Google's market share is significant. So, can you talk a little bit about what you're doing with Perplexity and how search might be evolving? And does that put you in a position of not only competing with Nvidia but maybe Google as well?
Sure. Perplexity is the world's leading AI search engine, right? If you want if you want to get an answer to a question as opposed to a page of links, you use Perplexity. It's not maybe as famous as ChatGPT, but all the people who are power users love it. Like they cannot get enough. I use it all the time. It is a disruptive force to Google because exactly it provides you the answer as opposed to a bunch of sources. And consumers obviously would prefer that. And the reason it can do this is because all of the backend technology is based on large language models, right? It will basically read through many documents, identify exactly the answer, suck it out for you, rewrite it, and give you exactly that answer. That's the fundamental new technology that makes it work. The maybe best way to understand how we got working with Perplexity is to think about Perplexity from their point of view. The founder of the founder of Perplexity came from OpenAI, and he could see the potential of this product, obviously while working there. And they indirectly also compete, increasingly directly compete with OpenAI, because OpenAI, when you ask it a question, what are hot stocks to buy this year, it has the ability to search the internet. It has a little globe and called search. When that is on, it will go search the internet and read a lot of articles and then come back with the answer. That's basically the same product or value proposition as Perplexity. It wasn't always like this, but now it's like this, right? Because everyone wants answers and they want real-time answers with internet data. So from Perplexity's perspective, and this is just how I would interpret their reality, they have to essentially compete against both Google on traditional search and OpenAI on this new AI-empowered search. OpenAI obviously has vast resources. They can train their own models. They have a huge amount of data centers from Microsoft. So from Perplexity's perspective, they can differentiate a lot, and they've done an amazing job differentiating on the product side. But they, I think, ultimately want even stronger differentiation. They need to be able to do something. They need to be able to offer to their customers something that OpenAI cannot offer, right? And that's, I think, where we come in. If they use, and they do, have historically used traditional GPU hardware, they can essentially produce the same rough experience as what ChatGPT with web search can do, which is take about a few seconds and return the answer to you at about 100 words per second. We approached them and said, hey, basically we can take exactly what you're doing right now. We can run exactly the model you're running, so we won't change the answers at all, no work on your part, but we can return the answers 10 to 20 times faster because our chip is 10 to 20 times faster. That's what we provide for them. And that's what the release we did with them enables. If you're a Perplexity Pro, which is their kind of paid premium tier, you can get answers back like basically 10 times faster than a GPU. And this means they're not only the world's leading AI search engine, they are 10 times faster than ChatGPT, which is not something that a lot of companies can claim, right? That's basically saying you're 10 times better than the thing that is the best and what is everyone using today. So our strategy and our value proposition to our customers, especially leading AI company customers like Perplexity, like Mistral in France, is to give them something highly differentiated so that they can compete against the top AI labs in the world, like OpenAI and Anthropic, right? We make their stuff run 10 times faster, so their customers have a reason to pay for the pro tier and to stick around to their service.
Okay, thanks.
I want to look into something that when I first spoke to Cerebras, one of the plans was to build like 9 supercomputers, and I was like, whoa, that's a lot. How far along are you with that, with that plan? Is the strategy still the same, and what is the purpose for all of those supercomputers?
Yes. So we started off as a chip company and then a systems company. It wasn't really part of the initial plan to build a bunch of data centers. But the market has a way of changing your plans, and it's the first data center we built in Santa Clara was just we needed it to be able to demonstrate to us and to the world what the product can even do. And the product had evolved from a single box offering to a clustered offering with 64 systems. So we built our first data center in Santa Clara to show to the world that we can do large scale model training. And that was very successful. That's what put us on the map. We put out a series of open weight models called Cerebras GPT in 2023, I think. And then that led to like the huge amount of engagement we got from customers and G42 and so forth. So that was the kind of initial motivation, which is to build enough. It was necessary as a technology demonstration and as a runtime environment to do the work. With Inference, the demand is basically not only exponential, but kind of unlimited, right? After we launched Inference in August, tons of customers wanted to switch over, and we didn't have enough like capacity and servers to be able to serve all of them. It's a wonderful problem to have, but you have more customers than you can serve, essentially is the kind of situation we ended up with almost overnight. And that was kind of the motivation behind this idea to dramatically expand our data center footprint. So the current plan is to build data centers across the entire North American kind of like geography. We have data centers now up and running in 2 sites in California, in Texas, and we're ramping up Minneapolis right now with increasing number of servers. And by the end of the year, we'll also have servers on like Montreal, as well as I think Oklahoma City as well. So it's a huge expansion. And in effect, we are saying in this day and age, pragmatically speaking, if you want to really directly serve your customers, a huge amount of customers in the inference market, the avenue to do that is an API. And if you're going to serve it our API, then essentially you have to own the hardware, right? And we're in the process of transforming into like a cloud computing company with our own data centers. That's kind of the evolution.
Okay, so no AI podcast could be completed without a discussion of agentic AI, right? The trendiest topic in the AI world right now. So, what's Cerebras doing with agentic AI, or are you developing any agentic products?
Yeah. So, agentic AI is essentially AI that uses multiple requests back to back or in parallel together to accomplish a more difficult and complex task. Once we had reasonable single answer responses, it became pretty obvious. Hey, if you chain them together, you can do all kinds of things. You can have it write a research report for you, read 500 books, 500 articles, do some analysis on the side with Python, and then generate a whole research report for you. And many companies are doing that. The important thing to recognize here is for any agentic AI application or workflow, the fundamental unit of work is still a single request, right? So it's just built up of many, whatever the big task is built up of many singular tasks, which is no different than you asking ChatGPT, how do I make a turkey sandwich, right? So if you are fast at the single request, by definition, you are fast at the multi-request. Which is to say, we are basically perfectly set up already. We don't have to do anything different or special. We provide the kind of like fundamental bricks, and it's up to the application developer to put it together into whatever shape they like. For general chat, the speed that we provide is nice, but maybe not critical for some users. Like whether it takes 1 second to get an answer back from ChatGPT and 5 seconds is maybe not, world changing. But for agentic AI, it is dramatically different, right? Because you might, you're trying to write a research report. Maybe on the traditional hardware, it takes 20 hours. Like you can't even finish that in time. On us, it would take 1 hour and you can submit it. It's done, right? It's the difference is no longer quantitative of like very fast versus kind of fast. It is, can you get it done in time or not? Does it work or not? So for agentic workflows, the speed we offer is of universal benefit. And previously, when we first launched, people are like, oh, can people really read faster than 100 words a second? Like people got tied into like what people's reading speeds and what is good enough for speed. The great thing about agentic AI and its kind of other neighboring applications like reasoning and code generation is that there is no top speed that is good enough, right? No, there is no such thing as if you can generate code at 2,000 tokens per second, that's good enough. Like every developer, after you give them 2,000, they'll be like, can we have 5,000? Can we have 10,000? There's no benefit to waiting. There's no such thing as good enough. And the workload is unbounded in complexity. So it's not like giving like 500 words on a summary of like ancient history. It's literally refactor a code base. There are a million lines of code in here. You will never finish, right? So it's a wonderful problem and it benefits from speed. And all the people who are building agentic applications now are in demanding speed. And we're very happy to serve them. And we've worked with some of the best startups from YC and others in helping them build agentic AI.
One of the things that you also included was DeepSeek's R1, right, model in your stack. What is your approach when you're thinking about the models that you're including in your stack? What role do you see do you see Cerebras having in the development of the future of AI models beyond the current large language models?
Our goal is to basically to serve the models that developers want. That sounds simple, but it's in practice quite hard because the model leaderboards change on a weekly basis. And 1 second they want it, next second it's on to the new hot thing. And R1 is a very special one. R1 is the first model that literally broke the internet. Well, after ChatGPT, the first model that broke the internet, right? Literally, it became number one on the Apple App Store, which is, to this day, I kind of cannot comprehend for a Chinese chat app that takes 60 seconds to give you an answer. It destroyed Nvidia stock price for like a week. This is kind of crazy. And it's a pretty good model, right? It has multiple layers of implications. But if you look at it today, actually the amount of interest in R1 has dropped off significantly. Like we had a fever moment and then everyone kind of tried it. And here's the thing, right? R1 is what's called a reasoning model. So it doesn't give you the answer back right away. It thinks internally, which is say it prints a bunch of tokens internally, debates with itself. It's kind of like talking to yourself in your head for about a minute. And then it gives you the first answer. It's like, aha, now that I've thought about it, here's what you do. Now, the benefit of doing this kind of contemplation cycle is that you can increase the quality of the answers, especially for questions that require multi-step like reasoning, right? If you ask it a very complex mathematical problem, it cannot just instantly print the answer in the token out in a single shot, right? It has to, like a human, it would have to do the line by line of derivations and then get to the answer. And that takes tokens and therefore time. So these reasoning models are great because they give you better answers, but they just take too long. They take about a minute rather than a second. But that's just that to us, that was the best thing ever because all of a sudden, right, all the GPUs are not good enough and we can give you the answer back in a second. So we love these reasoning models like R1. Now, R1 by itself was a great model and we're working on it. We want to get it out. But recently there's been a much more lighter weight reasoning model called Qwen 3. This is by another Chinese company, Alibaba. I think their internal goal is basically to be DeepSeek, and they've made great progress. So Alibaba came out with the Qwen 3 series of models, which are also open weight, also reasoning models. They're hybrid reasoning, so for simple questions, they won't, like contemplate for a minute, but for more complex ones, it will, which is great, and performs on par or better than R1. So it's a wonderful release, and that's why we decided to kind of like support this as quickly as possible. We came out with our DeepSeek, with our Qwen 3 32B release. This model is comparable to like R1 and O models in accuracy, completely surpasses GPT 4.1, which is like the standard ChatGPT interface in kind of like in model intelligence. And we can return the answers at over 2,000 tokens per second, which is incredibly fast. Just the whole page in a single go. So I'd say this is probably our most important model release to date. We give developers what they want, which are reasoning models, but we give them single-second reasoning rather than 60-second reasoning on GPUs. And no one else can do that.
Okay, so we're going to wrap up soon. So as the generative AI landscape evolves so quickly, Agentic AI, maybe something else next year. How does Cerebras plan to evolve and continue to define yourself? Are you still like an AI? Are you a chip maker? Are you a AI systems platform? What are you going to be in the future?
I think the new competency we are developing is being a good cloud and API product company, right? It's no longer sufficient just to have a good chip. It's a good thing we have the fastest chip in the world, but that's like the base level requirement. For anyone to use it, they use it through an API. So we have to be good as basically now a software company, right? Which was not in a web sense, not in a software stack sense. And I don't think being a good web company or a cloud services company was in the original kind of like scope. And that is a capability we built up in the last year or two. We will continue to build that very aggressively. Behind a web front end implied is a huge amount of hardware backend, and that is the data center side. So we're ramping out data center capacity dramatically in the US. We literally will have the capacity to serve something like 40 billion tokens per second by this year, which is enough to serve every US person, right? That was pretty incredible capacity. That's like national grade capacity. And we also need to remain competitive performance-wise and keep our gap versus GPUs. Nvidia is not resting on its laurels. It's launched Blackwell. Next year's later, is Blackwell Ultra. We have enough performance to, take care of all of that, but obviously there's more. And we have our next generation hardware as well, which I'm quite excited about. So I would say the key for us is having a really good understanding of what AI developers need, which are the latest models, whether it's DeepSeek or Qwen or OpenAI models, and being able to support them, right? Us being able to run their models. Like if our value proposition is whatever models you're running, we just go 20 times faster, no meaningful change in cost, we will do wonderfully. But that's easier said than done. And that's basically what our team from hardware to kernel to web APIs is all focused on.
Thank you.
Thank you so much, James. This has been so good. I really appreciate you coming on our podcast and kind of breaking it all down and not shying away from our questions about Nvidia and all of that. So thank you to our audience for listening as well as watching. Please feel free to check out Cerebras' website, as well as check out all of the articles that we've written about Cerebras on the Informing Tech Targets website. Please leave a review, share, comment, and we'll see you next time on the Targeting AI podcast.
To hear the full audio podcast, please go to Apple Podcasts, Spotify, Amazon, Audible, TuneIn, Podbean, and other popular podcast platforms.